Hello. Good evening, everyone. Hope you can hear me well. Yes. Shall we start this very quickly? Can you all hear me? So this is the tutor, like I said today, this tutorial, right? Tutorial number one. We are in the mid page, page number 7. I think we discuss the one that is given as 9 to 3. So starting from 9-4. What do you say? 9 to this is 4. Let's try to work on that, right? Can you hear me first? Tell me that. Is it clear? Just quickly. Someone. Oh, yes. All right. Good. Excellent. Excellent. You can hear me, right? Good. Let's work it out. Question number 4, right? Question number 4. It says a sodium hydroxide solution contains 70% sodium hydroxide by weight. So you have a solution here and it says 70% by weight. So 70% by weight, sodium hydroxide weight is that. Then if 200 milliliters contain 1.4 moles, 1.4 moles of sodium hydroxide, calculate the density of the solution. So what you can do is you can say density is D. Density is D. So what is the mass? Mass is equal density times volume. Density D, volume is 200 milliliters. So density D in grams per cubic centimeter, right? So here it is grams per cubic centimeter. Here it is cubic centimeters. So you get it as grams. That is the mass of the total solution. So what is the mass of sodium hydroxide? Mass of sodium hydroxide is 70%. So D times 200 multiplied by 70 divided by 100. 100 and this is 2. So this is 140 D. 140 D grams. This is the mass. What is the number of moles? Number of moles is equal mass divided by molecular mass. What is that? 140 D divided by molecular mass is 40 grams per moles. This value is equal to 1.4 moles, right? So this is going to cancel out. What else? 1.4 is equal to, you get 1.4 again, 10. I think, right, D is equal to 4 divided by 10. You get it as 0.4 grams per cubic centimeter. Is it clear? Did you all get that answer? Everyone? Right. Excellent. Okay, so that is 9-4, page number 70. Let's go to question number 10-1. Right? Tell me what are the things that you really want to discuss there, right? So, okay, then we can do a kind of a meaningful discussion rather than if there are easy questions, rather than staying there, we will move on to this. If the volume of sulfur dioxide STP is 13.44, then calculate the number of moles of sulfur dioxide. So what you get is number of moles is equal V divided by VL, right? So 13.44 10 to the power minus 3 liters divided by 22.4 liters per moles divided by the molar volume. You get used to these kinds of 13.44 10 to the power minus 3 divided by 22.4. That is 6 10 to the power minus 4. 10 to the power minus 4 moles. What do they ask? They ask you to calculate the number of moles. 6 10 to the power minus 4. Is that what you get? Everybody okay with that? All of you got those answers? Right. Question number 10-1. Question number 2, is it all right? Question number 2 also I'll do. It says calculate the STP of a sample containing 29 10 to the power 20 molecules of nitrogen. So what is the number of moles? Number of moles is N divided by L. N is equal to 24.088. 10 to the power 20. Divide by L is equal to 6.022 10 to the power 23. So this is the moles. What is that? 24.088 10 to the power 20 divided by 6.022 10 to the power 23 gives you 4 10 to the power minus 3. Number of moles is 4 10 to the power minus 3. What do they ask? Calculate the volume. Number of moles is equal V divided by VA. So therefore, volume is equal to number of moles times molar volume. Number of moles is 4 10 to the power minus 3 moles. What is the molar volume? 22.4414 liters per moles. I'll take only this one, right? So what is the answer? 4 10 to the power minus 3 multiplied by 22.4 is equal to 0.0896. 0.0896. Did you get that answer? If you got the answer, tell me, so that I can move like in a little faster, right? Like confirm. Right. Okay. Yeah, somebody is confirming this. Right. Yeah. Okay. Good. Let's look at the question number 3. Question number 3. It says something like that. A certain mass of calcium react with water to produce 4.48 of hydrogen at room temperature. Calculate the amount of water mixed in the to the calcium, right? So calcium plus water. What are the products? It gives you hydrogen, but other than that, what is the next one? Calcium hydroxide. Calcium hydroxide is the other product that you get. Let us balance the reaction. Two hydrogens, altogether 4 hydrogens. This is what you have. So, produce 4.48 hydrogen. 4.48 cubic decimeters. Is it clear? So what is the amount of water mixed with? So what they ask is, what is the amount of water? Right. So let us look at the number of moles. You have to always compare the number of moles. Number of moles is equal volume divided by molar volume. What is that? 4.48 divided by 22.4 liters. Liters divided by liters per moles. So liters and liters cancels out. You get, what is the answer? 4.48 divided by 22.4 is equal to 0.2. 0.2 moles. Did you understand that? If you have 0.2 moles of hydrogen, you know the number of moles of water, double the amount. So number of moles of hydrogen to number of moles of water is equal to, if hydrogen is 1, water is 2. So number of moles of water is 2 times hydrogen. What is that? 0.4 moles. 0.4 moles. That is what they ask. Room temperature, calculate the amount of water mixed in calcium. Is it clear? 0.4 moles. Right. Okay. Did you understand that? Did you get that answer? Room temperature calculate? Really? Yes. If it is room, yeah, I forgot that. Room temperature and 24. You divide by 24. This is 22.4. I'll look at that. This is at STP. It is STP. Yes. If it is room temperature, number of moles is equal volume divided by molar volume. What is the volume? 4.48 cubic decimeters. 24 cubic decimeters per mole. Right, that is cancelling out. What is that? 4.48 divided by 24 gives you 0.186. Then number of moles of water should be double the amount. 0.186 times 2. 0.373. But then better answer is that room temperature is not very specific. Na? So, I think it is STP is a better way to work it out. Because you get the kind of a proper division also. Otherwise, 24 is at 25 degrees Celsius. But it doesn't mention 25 degrees Celsius properly. So we'll take it as STP, right? I think that is better. But I can understand what you said there, right? Okay, question number 4. Go to the next page. Question number 4. Calculate the mass of 112 milliliters of volume of carbon dioxide at STP. Number of moles is equal volume divided by molar volume. Volume is 112 milliliters, 10 to the power minus 3 liters. This is 22.4 liters per mole. Liters and liters cancels out. So you get 112 10 to the power minus 3 divided by 22.4. 5 10 to the power minus 3. This is the number of moles of carbon dioxide. What is the mass? So mass of carbon dioxide is equal number of moles times the molecular mass. 5 10 to the power minus 3 multiplied by 44 grams. Multiplied by 44 grams, you get 0.22 grams. Is it clear? Everybody understood that? Right. Everybody okay? Yes. Then I will go to the next question. It's like, numbering. Now I am the one who is typing these numbers. Sometimes it goes all kind of wrong, right? So that's why like the kind of issues there, right? Okay. Right. Question number, well, like it says 4. After that 4, you have 1. It says 1, right? So there's a kind of a reaction that you need to look at. A 42.4 gram sample, there's a mixture of potassium and Fe. You have potassium, you have Fe, right? By reacting this mixture with water, when you add water, iron doesn't react. Iron normally don't react, right? Potassium very quickly reacts to give you KOH, potassium hydroxide, and hydrogen gas, just like calcium did. Only thing is calcium has a valency of 2, potassium has a valency of 1. So if you balance it, 2 here, 2 here, and 2 here, right? This entire mass, potassium and Fe, this entire mass is how much? 42.4. 42.4 grams. By reacting with mixture with water at STP, it gives a volume of 8.96. So hydrogen gas, this is the only thing that gives you hydrogen gas. It has a volume of 8.96 liters. At STP, at STP. Calculate the moles of Fe in the sample, right? So let us look at, now this is the only thing that is known. From hydrogen, you can look at the amount of potassium. If you know the amount of potassium, you can calculate Fe because you know the total weight. So that's my plan, right? So first of all, let us look at the number of moles of hydrogen. How do you calculate the number of moles of hydrogen? Volume divided by molar volume. What is the number of moles? 8.96 liters. Divide by 22.4 liters per moles. Liters, and it gives you 8.96 divided by 22.4 gives you 0.4. This is the number of moles of hydrogen, right? If you know the number of moles of hydrogen, you can calculate the number of moles of potassium. You can see stoichiometry is 1:2. So number of moles of potassium to number of moles of hydrogen. Hydrogen is 1, potassium is 2. So what is the number of moles of potassium? 0.4 multiplied by 2 is equal to 0.8 moles. That is the number of moles of potassium, right? If you know the number of moles of potassium, you can calculate the mass of it. So what is the mass of potassium? Mass of potassium is equal to 0.8 multiplied by potassium is 39 grams. What is that? 39 times 0.8. is equal to 31.2. 31.2. The total mass is given as 42.4 total mass. So you can now calculate the mass of Fe. Mass of Fe is, what is the total mass? 42.4. 42.4 minus 31.2 grams. Right? What is that? 42.4 minus 31.2. 31.2 is equal to 11.2 grams. What do they ask? They ask you to calculate the moles of Fe. Number of moles of Fe is equal to mass divided by molar mass. 11.2 grams divided by molecular mass. Molecular mass is 56 grams per moles. Check whether you got those answers. 11.2 divided by 56. Here the 0.2. 0.2 moles. Right. Let me check your whatever the questions that are there. So why Fe can't react with water when potassium is present? Normally iron doesn't react with because it has a very low reactivity. Iron doesn't react because potassium is a very reactive metal. Which group one? Group one. Iron doesn't react in that speed. It doesn't give it. It reacts with acids. But water is not acidic enough for it to react. It might rust very slowly. Rusting is a very slow process. Hydrogen is given by only by potassium. All right. So you can write it down. You can write it down. Now, you should not worry about those things much because we will discuss this all these reactions that you encounter again under SPD block elements. That is group unit number 6. At the moment we are finishing unit number 4, and then we'll start energetics and SPD. SPD, you will see this, right? You will see this. Now, whenever you encounter new reactions, you write it down at that place and then make sure you continue with those things. It should not be a burden. Right. Okay. So did you understand that question there? Did you understand everything that we discussed there? If you're okay with that, I will go to the next one. Sure. Any other questions? Yeah. Any other questions, Pata? Let's move on. Right. Okay. So question number 11. Question number 11, part A. This is actually exam question, I remember. This is exact exam question that is there, right? So it's a MCQ. Calculate the mass of sodium chloride that contains total number of moles of ions present in 285 grams of magnesium chloride. So what is the mass of sodium chloride that contains the same number of moles of ions in 285 grams of magnesium chloride? So let us say magnesium chloride. Magnesium chloride. You dissolve this, it breaks into ions. You know that magnesium plus 2 aqueous and then 2Cl minus aqueous. What is the number of moles? Number of moles is 285 grams divided by molecular mass of magnesium chloride. What is the molecular mass of magnesium chloride? Magnesium is 24 plus 35.5 times 2 is equal to 95. 95 grams per moles. That gives you, how many moles did you get? 285 divided by 95 gives you 3 moles. So if you have 3 moles, Puta, right, magnesium chloride, if you dissolve 3 moles, you get 3 moles here, magnesium 3 moles. Why? Because it is 1:1. So this is 1:1. But here it is 2. So you get 6 moles. So therefore, total number of moles is 9 moles here. Altogether, ions, 9 moles. Check whether you understood that part. Did you understand that? Did you understand that there are altogether 9 moles? Takgala danda. Yes, kila kadanda. Padas gala. Right? Understood, right? Okay. Right. Clear? Okay. Right. So I'll move on. Right. So altogether 9 moles. Now what they ask is, what is the mass that you need to have to get the same 9 moles when if you are using sodium chloride? Sodium chloride, sodium you get 1 mole, chloride also you get 1 mole, right? So if you dissolve X moles here, you get X moles of sodium, X moles of chloride. So you can see 2x is equal to, should be 9. So therefore x should be 4.5. So if you dissolve 4.5 moles, make a 4.5 moles if you dissolve, you get 4.5 moles of sodium, 4.5 moles of chloride, altogether 9 moles in sodium chloride, right? So we have to dissolve 4.5 moles of sodium chloride. So what is the mass? Mass is equal number of moles times the molecular mass is equal to 4.5 moles. What is the molecular mass? 23 plus 35.5 is equal to 58.5 grams per moles. So moles cancels out. 58.5 times 4.5 gives you 263.25. Check whether you get that answer. 263.25 grams you should dissolve. Then only you get this, right? Yes. Very good. I hope all of you got those answers. Right. Very good. Well done. Right. So part B I won't do. It's an easy question. Part C I'll do. Right. Part B, I'm sure it's an easy question. Part C I will give you. I think part B you get an answer 1.6 again. 1.6 grams. Somebody says 1.6 grams here. I don't know whether it's the right answer, but then somebody has written, I got 1.6 grams. 1.6 never. Someone else is saying 16 grams. 16 grams. A lot of people say 16 grams. Double check your answer, right? Okay, right. Part C. Let's look at that. Each of compound Z contains 2 atoms of sodium. There are 2 sodium atoms, Na2 something. We don't know what is that. 2 sodium atoms. The mass percentage of sodium in this sample is 10%. This is, if you look at the entire mass is capital M, this part is 10%. 10% is that. Okay. Calculate the molecular mass of Z. Right. Let us take the molecular mass as capital M. Capital M. Sodium is 23. 23 times 2, 46. 46. 46 divided by M multiplied by 100 is equal to how much? 10%. Right? So this and this cancels out. This and this cancels out. So that the molecular mass is equal to 460 grams per moles. Is it clear? Did you get that? Confirm, Karanda. Right? Right. Can you confirm the answer? 460 grams per moles. Will you confirm? Right. Okay. Yes. Yes. Okay. Lot of yeses. Lot of yeses. Right. Good. So how do I solve questions with atoms? Question 11B. 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 අනේ කරන්නේ යෝ පොඩි එකක් තියෙන පුතා එක. 11B. You should try that. හරිද දැන් calculate the mass of calcium in which equal number of calcium atoms present in 12.8 grams of sulfur, right? So 12.8 grams of sulfur divided by 32 grams per moles. That gives you the number of moles of atoms. Number of moles of atoms. What is that? 12.8 divided by 32 is 0.4. 0.4 moles. That is also a number. Right? Calcium also you should have 0.4, right? So number of moles is equal mass divided by molecular mass. So number of moles is 0.4 moles. What is the molecular mass? Molecular mass is 40 grams per moles. It's right. So mass is equal 0.4 multiplied by 40 grams. 4 times 4, 16, 160.16. 16 grams. Podi that thing. Clear? Everybody okay? Right. Hari. Right. Go to the next question, D. Yeah. Next question, D. There is 36% water. 36% water in MSO4.XH2O. Calculate the value of X in the sample, right? So if you look at water, MSO4.XH2O, this is 36%. Right, 36%. What is this part? This part is 64, right? 64%, right? So what they ask is to calculate X, na? Right. What is the molecular mass? M is 64. Sulfur is 32. Oxygen is 16 times 4, 64. Plus 18 X. What is this part? Make it 64 plus 32 plus 64 is equal to 160. 160 plus 18X. So it is 64%. Right? So what is that? MSO4 divided by MSO4.XH2O. .XH2O multiplied by 100 is equal to 36%. That's what you have. Right? MSO4 molecular mass is 60. Make this part. 160. Divide by 160 plus 18X is equal to, make a 36, make a 64 window. Yeah? This is 64. Multiplied by 100 is equal to 64. No, it's right. Right, 64. 8 times 8, 8 times 8, 8 times 20. So this is 10, this is 4. So 1000. 1000 is equal to 4 times 160 plus 18X. 4, this is 250. Right? 18X is equal to 250 minus 160. 90. X is equal to 90 divided by 18, 5. Did you get that answer? Answer is 5. Yes, someone is like, confirming this. Question number 11C. 11C, can't we consider the answer as 92? 92 never 460. You can't have 92. How can you have 92? You can send me the calculations later. Harid, if you want to look at it. Harid, did you understand that? Make Harid. Are those small questions you need to do. You can do all these big questions. Right? Okay. Any method, doesn't matter. You don't have to use this method that I use. Right? If you can come up with a method, then if it works out, no problem. Right? Okay. Right. How about E? Did you do the E? E. Simply. Molar mass of a compound X is 160. The mass percentage of oxygen in this sample is 80%. Calculate the total number of atoms of oxygen. Right. Okay. So if the molar mass is 160, what is the mass of oxygen? Mass of oxygen. Here. 160 times 80 divided by 100. So mass of oxygen is 16 times 8 grams. So what is the atoms of oxygen? Number of moles of atoms is equal to 16 divided by 8. Molecular mass of a single oxygen atom is 16. Put 16, 16, you get 8 atoms. Every molecule should have 8 atoms. This is because this is the molecular mass that we have taken. Right? Can you please explain question number 4 in page number? Then it's like too late. Question number 4. I have given answers. You can watch the recording also. Right? Double check. Right. So 8 atoms is what you get. Right. Come the F. Did you try F? Did you try F? Compound R contains 4 atoms of magnesium and its mass percentage is 20. Calculate the molecular mass of the compound. 4 atoms. So magnesium is molecular atomic mass is 24. 24 times 4. Divide by capital M. Molecular mass is capital M. And there are 4 atoms. And if you take this as 100%, value is 20%. Right? So 20, this is 5. Right? M is equal to 24 times 5 times 20. 5 times 4 is 20 grams per moles. What do you get? 24 times 20. 24 times 20. What did you get? 480 grams per moles. Somebody has to confirm. If you got it right, put it in the make as a courtesy. Right, okay. 480, 480, right? 480. Okay, okay. Yes. Right. Okay. Right. It was a question number. Right. Shall we go to question number 12? Did you get those answers? Question number 12. These are kind of very simple questions now. What is the mass of 0.1 mole grams of this substance? Right. First one, sodium carbonate. Mass is equal number of moles times the molecular mass. Number of moles is 0.1 moles. What is the molecular mass of sodium carbonate? 100, 106 grams per moles. 106, I think. So you get 10.6 grams. Clear? Right, 10.6. Very good. Ammonium tetraborate, B. M is equal N times M. So I'm going to calculate the molecular mass, 0.1 mole. You tell me what is the molecular mass. I'll check. Ammonium, 14 plus 4, 18. 18 times 2. Plus boron is 11, 44. Plus oxygen is 16. Plus 16 times 7. 100. What did you get? What did you get? What did you get? 192. 192 grams per moles. If you miss certain things, this will be uploaded. You can go through it again and double check your answer, right? 19.2. Right? 19.2. Very good. Very good. Right. Okay. C. Part C. What is that? This calcium silamate. Calcium silamate. N is equal M times capital M. Capital M times N. This is M. Right. 0.1 moles. What is the molecular mass? Right. Let us look at that. 72 plus 12. Nitrogen is 14 plus 32 plus oxygen 48 multiplied by 2 plus 40. I got 396. What did you get? 396. Did you get 396? Right. Okay. 396 grams per moles. So per mole cancels out 39.6 grams. That is the molecular mass. Right? Everybody okay with that? Right. Question number 13. How does it sound to you? Did you get that? How many moles of sodium nitrate in 1.7 grams of sodium nitrate? The very easy, number of moles is equal mass divided by molecular mass. 1.7 grams. What is the molecular mass of sodium nitrate? 23 plus 14 plus 48. 85 grams per moles. I have given this very long time back ago, but this is like a kind of a quick revision also, 0.02 moles. Right. Go to the next one. Question number 14. Did you do the calculation? Question number 14. Do you have an answer here? Anybody having an answer, you can share so that I can put it there. Right. How many grams of ammonium sulfate are in 35.8 grams of moles of ammonium sulfate? Any answers? How many grams? Somebody is saying 14.47. And then I mean, there are so many decimal places here. Okay. Right. Question number 15. I'll avoid question number 14. Go to 15. 0.55 moles of sample table sugar weighs how many grams? Table sugar weighs how many grams? Right. So mass is equal number of moles times the molecular mass. What is the number of moles? 0.5 moles. What is the molecular mass? Here, 342 is what you get. Is that what you get? 342, yes. 342 multiplied by 0.5 is equal to 171 grams. Question number 15. So I'll leave 16 and then, okay. Let us do 16. It's like, it sounds difficult also and it looks like that. A solution of zinc chloride in water is used to soak the end of the wooden fence post to prevent them from rotting while they are stuck in the ground, right? One ratio used 840 grams of zinc chloride in 4 liters of water. How many moles of zinc chloride are there, right? So number of moles is equal mass divided by molecular mass, 840 grams. What is the molecular mass of zinc chloride? 35.5 times 2 plus zinc is 65. Altogether 136 grams per moles. Grams and grams. 840 divided by 136. 840 divided by 136. What did you get? 6 point. What have we seen? 6.17 here. 6.17 moles. Is it clear? Did you get that answer? 6.17, yes, 6.1718. Right, good, good, very good, right. Question number 17, 16 is that. 17, I'll leave you to work out. Question number 18. 18, right? Borazone is one crystalline form of boron nitride, Bn. Is very likely the hardest of all substances. If one sample contains 3.02 atoms of boron, how many atoms and how many grams of nitrogen are also there? So this molecule or this compound contains 1 boron to nitrogen, 1 nitrogen, 1:1 ratio. So if you have 3.02 10 to the power 23, nitrogen also 3.02 10 to the power 23 atoms. Now, how many grams is there, right? Number of moles is equal capital N divided by L. 3.02 10 to the power 23. 6.022 10 to the power 23. So this will cancel out. So 3.02 divided by 6.022 is equal to 0.5. 0.5. 0.5 moles. So what is the mass of nitrogen? Mass of nitrogen is number of moles times the atomic mass. 0.5 atomic mass of nitrogen is equal to 14 grams. So is equal to 7 grams. Check whether you got those answers. Everybody? Everybody, did you understand that? Right. Okay. So like question number 19, I'll let you do it. Right? Let you do it. Question number 20. Right. 20. Let's see how that is going to work. Ammonium carbonate is used as a fertilizer and to manufacture explosives. How many atoms of nitrogen are in 0.665 moles of this substance? How many grams of ammonium nitrate supply this much of nitrogen? Right, okay. So let us look at this one. Ammonium carbonate, NH4 twice, CO3. Number of moles of this substance is 0.665. 0.665 moles. What is the number of moles of nitrogen? Number of moles of nitrogen is 0.665 multiplied by 2. 0.665 multiplied by 2. 1.33. Then it says how many grams of ammonium nitrate supply this much of nitrogen. So 0.665 moles, right? How many grams? Mass is equal number of moles times molecular mass. The number of moles is 0.665 moles. What is the ammonium carbonate molecular mass? Nitrogen is 14 plus 4 is 18 times 2 plus 12 plus 48 is equal to 96. 96 grams per moles. Moles per moles cancels out. 96 times 0.665 is equal to 63.84. Check whether you get this answer. All of you? Yes. Yes. What do you say? 63.84. Right. That was question number 20. I will leave question number 21, but we'll look at question number 22. They are all very similar questions, but let us do this. Question number 22. Barium sulfate is given to patients as a thick slurry in a flavored water before x-rays are taken of the intestinal tract. So the barium sulfate has a very low solubility. It's very, very low soluble. Barium ions are toxic, but because it is very low solubility, it goes through the tract, gastrointestinal tract without any absorbance of barium ions. When barium ions deposit in very small parts in the intestines, you can get a very good X-ray, right? It's very contrasting X-ray. It's like a kind of a reagent. Barium blocks the X-rays and track before cast a shadow that is seen on X-ray films. How many grams are 0.6568 of moles of barium sulfate? So number of moles, mass is equal number of moles times the molecular mass. Number of moles is 0.568. What is the molecular mass of barium sulfate? Barium is 137, sulfur is 32, oxygen 64 is equal to 233. 233 grams per moles. The per mole cancels out. 0.568 multiplied by 233 is equal to 132.344. 132.34. Right? Okay. Is it clear now? Everybody understood that? Right. Okay. So we will cross that next one also. We'll look at this. Now we have done very similar calculations. Right? Very similar calculations. They ask for the grams of ammonium nitrate. Ammonium nitrate. Ammonium nitrate. Did I misread this? Oh, how many grams of ammonium nitrate? Ammonium carbonate. It should be ammonium carbonate. Right? If you want ammonium nitrate, I think it's a mistake. It should be ammonium because we are talking about ammonium carbonate. If you want to get ammonium nitrate, it is slightly different. If you actually want to calculate ammonium nitrate, you think here you have nitrogen, here also you have nitrogen, two nitrogens. Two nitrogens gives you how many moles you had? 0.665. Even here also 0.665, it is enough. 0.665 moles is enough. So what is the mass? Mass is equal number of moles times molecular mass 0.665 moles multiplied by molecular mass of ammonium nitrate. 14 plus 4 plus 14 plus 16 times 3, 48. 80 grams per moles. 0.665 times 80. Ammonium nitrate 53.2. If it is really that, but I think it's because we are talking about ammonium carbonate, but it's okay. Yeah. Right. All of you have done it using ammonium carbonate. Yes. Right. Okay. Now, the next one is calculation related to the industrial scale acids and bases. Right. Now, I hope you remember this. We did a lot of calculations based on this also. Right. Earlier, we did a lot of calculations between using this. Right. Okay. So, they asked for the number of atoms in nitrogen in question number 20. How many atoms of nitrogen? Yes. Yeah, you can do this maybe using Avogadro's constant. Calculate the number of moles of sodium hydroxide present in the described sample. We have two such data. Assume sodium hydroxide solution contains 60% sodium hydroxide by mass. 60% sodium hydroxide by mass. Right? This is sodium hydroxide. Density of this sample is 0.8 grams per cubic centimeter. Grams per cubic centimeter. Right. Calculate the number of moles of sodium hydroxide present in 20 milliliters of the sample above. So density is equal mass divided by volume. So therefore mass is equal density times volume. What is the density? 0.8 grams per cubic centimeter times what is the volume? Volume is 20 milliliters. This and this cancels out and you get 0.8 times 20 is equal to 16 grams. So this is the total mass of this sample. What is the mass of sodium hydroxide? Mass of sodium hydroxide is 60%. So 16 grams, you have 60 divided by 100. What is that? 16 times 60 divided by 100 is equal to, what is the answer that you get? 9.6 grams. Is it clear? 9.6 grams. Did you get that answer? Yes. Others? Yes. I hope you all got that. Now, the next one is a sample of sulfuric, weight to weight percentage purity, 98. Its density is 1.2. Calculate the concentration of the solution. So you know how to do this kind of a calculation also. You take the volume mass V. You can take the volume mass 1000. Volume mass 1000 we'll look at. That is the easiest way to do that calculation because concentration is an intrinsic parameter. It doesn't depend on the volume, right? So mass is equal density times volume. What is the density? 1.2. 1.2, this is 1000. 1200 grams. The percentage purity is 98. So mass of sulfuric is equal to 1200 multiplied by 98 divided by 100. Number of moles is equal to 1200 multiplied by 98 divided by 100. Molecular mass is 98 divided by the molecular mass. This is grams. This is grams per moles. So 98 cancels out, 100 and 100 cancels out. You get 12 moles. Now, if you find the concentration, concentration is equal to number of moles divided by volume. 12 divided by 1 liter. So 12 moles per cubic decimeter. And I told you the shortcut if you have a MCQ, if the density is what if the density is 1.2 and the percentage purity is same as the molecular mass, if you look at the concentration, it is equal to the density multiplied by 10. Density multiplied by 10. Right. Is it okay? Right. Question number 3. Let's do question number 3 also. A commercial phosphoric acid sample contains a density of 1.32. Its percentage purity is 90%. First of all, let us look at the molecular mass. What is the molecular mass? 3. Phosphorus is 31. Oxygen is 64. 98 is the molecular mass, right? So let us take 1000 milliliters. What is the mass? Mass is equal to 1320 grams. Density multiplied by 1000. Percentage of mass of phosphoric acid, H3PO4, is equal to 1320 multiplied by 90 divided by 100. Percentage purity is that right? Okay. So what is that? 132 multiplied by 9. What is the number of moles? 132 multiplied by 9 divided by 98. This is the number of moles. What is that? 132 multiplied by 9 divided by 98 is equal to 12.12. So concentration is equal to number of moles divided by volume is equal to 12.12 because it is in 1 liter moles per cubic decimeter. Is it clear? Right? How did you take the volume mass? 1000 milliliters. That's a kind of a very old question. Are the 1000 milliliters? Because it is an intrinsic. Volume doesn't depend on the concentration. Right? You can take any volume that you like. Concentration doesn't change. So we take it as 1000. That's the easiest way to do the calculation. Or else, like I did it in the class, you can do the volume as V and do the calculation. Finally, the volume cancels out. Because it's an intrinsic parameter. Right? Okay. What is, isn't it 108 grams per moles molecular mass? Nah. Double check your answer. Double check. It is not 108, it is 98. H3PO, hydrogen is 3. Phosphorus is 31. Oxygen is 64. Right? I think question number 4 and 5, I think you should be able to do it. If you have done it, can you tell me what is the answer? Question number 4. Somebody says 23.97. Question number 4. What did you get? 23.97. If you didn't get it, I'll do it. Moles per cubic decimeter. This is somebody else's answer. What you get? 23.9. Okay. 23.9. 24, 23.9. Okay. 24. Right, good. 24 23.9 Right. Yeah. No, මට හරියට උත්තරේ කියන්න ඕනේ. නිකන් මේ grams දීලා හරියන්නේ නැහැ. Right? 23.9. Yes. A lot of people say 23.9. Very good. Right. Okay. Question number 5. Oxalic acid. What is the answer? What is the answer? 9 point ගානක් කියනවා මෙන්න මෙතන. Right. Somebody is saying 9.53. 9.53 moles per cubic decimeter. Did you all get that answer? Can somebody confirm 9.53? 9.53, 9.53. Right, okay. In this tube now, give me a question that you didn't understand. Kauru hari innona? If there's a question, I will, before there's 6 minutes to go, in these 6 minutes, I can describe if anything that you didn't understand in this tutorial. Right, anything. Anything that you didn't understand. Explain question number 1 in page number 11. Question number 1 in Question number 1 in page number 11. Right. ඉතින් ඒකත් මේකම තමයි නේද? What is this? මොකද කියන්නේ? Assume 60% නේ. This means 60 grams of sodium hydroxide. Density is this much. Calculate the number of moles of sodium hydroxide present in the sample described below. Right, number of moles. So mass is equal density times volume. What is the density? Density is equal to 0.8 gram per cubic centimeter. Volume is how much? 20 cubic centimeters. So this is this. What is that? 0.8 times 20. 0.8 times 20 gives you 16 grams. 16 grams is the total mass. So what is the mass of sodium hydroxide? Mass of sodium hydroxide is equal to 16 grams multiplied by, what is the percentage? 60. Sodium, 60%. 100. 16 times 6. 16 times 6. Divide by 10. Here the 9.6 grams. So 9.6 grams is the number of moles of sodium hydroxide. Calculate the number of moles of sodium hydroxide present. This is the number of moles of sodium hydroxide present. That is the number of moles of sodium hydroxide. If you want to calculate the concentration, you can use that. Number of moles divided by volume. Here 9.6 divided by 40. This is moles divided by 20. 10 to the power minus 3. But what they ask is, they ask you to calculate the grams, 9.6. Hey, what is the problem? Yeah. Right. Anything else? Anything else? 11E කියලා තියෙනවා. 11E. What is 11E? From the point after finding 9 moles. කොහෙද 11 එක? Question number 11. We'll go to that. ඒක නම් ඔයාලට double check කරගන්න පුළුවන් මේ වීඩියෝ එක අපව බලලා. Question number 11. Where is that? මේක නේද? Right. So from the point after finding 9 moles. So 9 moles is magnesium and chloride. So sodium chloride also must contain the same number of moles. What is that? So let us say if you have X here, sodium is X, chloride is X. So altogether 2X. Altogether number of moles is 2X. 2X should be equal to 9 because both of them contain the same number of moles. 2X is equal to 9, X is equal to 4.5. 4.5 moles. What is the molecular mass? 58.5. This gives you that. Right. Can't be used molar volume equation. For what? You can use molar volume only for gases. You can't use for anything else. You can use only for gases. Vm, V divided by Vm. Molar volume is always defined for gases. Right? You can't use it for liquids. Right. Right, we will we will stop. Right? At this point, we will stop. Right? Okay. So this tutorial, first tutorial is done. First tutorial is done. Right? Now we go to the second tutorial. Let me show you the second tutorial. What is the second tutorial? Second tutorial is this one. It contains, not this one also. This is the one. It contains, yes, it can we talk about fractions, those kinds of things, right? You think you do the tutorial. I am sure that you have finished it by now. You do this tutorial. Mama, I'm going to look at the odd questions, right? While leaving one question after that. So meaning I'm going to look at the first question, then the third question, then the fifth question. So likewise, we move on. Well, because both like two questions, two questions nearby are very similar. So I want you also to do it. Right? So do that, and that I'll start that discussion next week. Right? Okay. So likewise, we will gradually go through this, and we are discussing some of these titration questions also in the class. So you become better at it, right? Then I am giving you a lot of space for you to improve. Lot of space is there for you to improve. right? Gradually you improve this. That's my only request to you, right? And I'm sending these challenge questions also. I'm going to give you 10 challenge questions. And I have some plans also. We'll see, right? Right? Do them. You are current node, right? Okay, Buddha. Good night. I will not take much time, right? Bye bye. I'll send a challenge question, but later in the night, because right, I have to talk with 2026 people also in a Chemeve, and later in the night I'll give you a challenge question. Try to answer that. Okay, bye.